Okay, dear students, in the previous video lecture, we have seen how to find inverse of a matrix by elementary row operations. We have one more problem here. Find the inverse of the matrix A is equal to 1 minus 1, 1, 4, 1, 0, 8, 1, 8, 1, 1 using elementary row operations. Okay, solution. First you write down the given matrix. Given A is equal to 1 minus 1 1 and so on, and consider A is equal to I3 into A. This is very important step. You should remember, all of you. A is equal to I3. What is I3 means? It is the identity matrix or unit matrix of order 3. Why I have written I3? Why I have not written I2 or I4? You remember, order of unit matrix must be equal to order of the matrix A. Okay, so order of the matrix A is 3 cross 3, rather 3. Therefore, I have to write I3 here. So next, after writing this one, next is, in place of A, you write down the given matrix. That is equal to, in place of I3, you write down the identity matrix or unit matrix. And you retain this A as it is. Don't substitute for this A now. Okay, you carry this A till the end. Next, after writing this, what we have to do here is, we have to apply series of row operation for this LHS matrix A to reduce it to the identity matrix. What are all the operations applied on A? The same operations has to be applied on the identity matrix. Okay, yeah. So now you see, the first row leading entry is 1. Next, you make below elements to be equal to 0. Okay, yeah. I will write down the row operations here. I am changing this R2 now. Here 4 we are having. So I am changing like this. R2 changes to R2 minus 4 times R1, and I am changing R3 also. R3 changes to R3 minus 8 times R1. Here the reading entry is 1, then making these two elements 0 is equal by using these two operations. So assume that instead of 1, here I am having the element say 3. Then what you will do? Yeah, suppose if I have 3 here, inevitably we have to divide that row by 3, so that 3 by 3 becomes 1, and here inevitably we get the fractions. Okay, so we are having 1 here, no problem in that case. So make the below elements to be equal to 0. Then in that case the matrix is now equivalent to, you see, first row I am not changing, 1 minus 1 1, write down them as it is. Second row I am changing, 4 minus 4 into 1 is 4 minus 4, that is 0. Okay, next 1 minus of minus, so calculations you have to write down them separately on the separate sheet. Okay, so I will take one separate sheet and write down the calculations. Let us write down the calculations here. So it is R2 means 1, that is 1 minus 4 into R1 means the element above that one. So that is equal to 1 minus into minus plus we get. So 4, 1 plus 4 becomes what? 5, that is. This is what is 5. Next, 0 minus 4 times 1 is minus 4. Okay, this is what we get after doing this operation. Now R3 operation. So R3 minus 8 times R1 is, anyhow this element is 0. Next this element becomes, R3 means 1 minus this 8 times R1 means this element, so minus 1. So I get 1 minus into minus plus 1 plus 8 become 1 into 8 is 8, so that the answer is 9 here. Is it right now? Okay, so next come to this element, 1 minus 8 into 1. 1 minus 8 is minus 7. This is what we get after applying the row operations to the LHS matrix A. Now the same operation has to be applied in RHS identity matrix. So therefore we get, see here, I am not changing first row, write down them as it is, write down it as it is, 1 0 0. Now I am changing R2, R2 minus 4 times R1, this minus 4 times this, 0 minus 4 into 1 is minus 4. Now this element becomes minus 4. Next 1 minus 4 into 0 is 1 only. 0 minus 4 into 0 is 0 only. Okay. Now R3 changes like this. R3 minus 8 times R1. This minus 8 times this is minus 8 now. Okay. 0 minus 0 is 0. Next 1 minus 8 into 0 is 1 only. You carry A as it is. This is what we get after doing these operations. Next, you have to identify what is the leading entry of second row. This is the second row. You see here the leading entry is 5. Note that it is not 1. In finding the inverse of a matrix by elementary row operations, you keep it in mind that leading entry must and should be equal to 1. Okay, here I have 5. We have to make it 1. How do you make this element 1? You can make it 1 by dividing the second row by 5. That is one method. Another method is, you see, are there any elements below that equal to 1? If I have an element below that 5, 1, then we can swap that row with this one so that leading entry becomes 1. But unfortunately, here we are having 9. But one thing you have to remember is that, you see, here I have 1. Don't swap R2 with R1 now. We have to swap the rows below the leading entry, not above. Okay, you should remember that one. So here I am having 1, so to get 1 here in place of 5, swap R1 with R2. If I do like that, this one comes here. Okay, then it will not reduce us to the identity matrix. So therefore, in order to make this element unity, you search for any element below that one to be equal to 1. If there is 1, then swap with that one. Okay, so here unfortunately we are having 9, so inevitably or no other way, so we have to divide this second row by 5. Okay, so I am using the operation like this now. R2 changes to R2 divided by 5 now to make this element unity R1. Okay, yeah, if I do like that, then now my matrix is equivalent to the first row I am not changing, 1 minus 1 1. Second row I am changing now, 0 divided by 5 is 0. Okay, 5 divided by 5 is 1. Here I get fraction now, minus 4 divided by 5. Last row I am not changing, 0 9 minus 7. Write down those two elements as it is. Next, here do the same operation on this matrix also. First row I am not changing, 1 0 0. So now I am dividing second row by 5. So I get minus 4 divided by 5 here, and then 1 divided by 5 here. 0 divided by 5 is 0 only. And I am not changing third row, so write down that as it is, minus 8 0 1, and you retain this A as it is. So now you observe that leading entry in second row is 1. So now you have to make the element below the leading entry to be equal to 0. Not only that, we have to make element above the leading entry to be equal to 0 to make this matrix to be equal to identity matrix. So to make 90 is equal to 0, I have to make minus 1 is equal to 0. So therefore, now I have to make this element 0. So I am changing R1 now. R1 changes to, so what is the row operation? R1 plus R2. Am I right now? This is minus 1, this is plus 1. If I add these two, you will get 0 here. Next, I have to change R3 now. So R3 changes to R3 minus 9 into R2. Am I right now? You multiply second row by 9, subtract it from this one. You see, I am making elements below and above the leading entry of second row. Therefore, I get R2, R2 here. R1, R1, R3, R3. Is that okay? Yeah. Next, after applying these two operations, we get the matrix equivalent to, now I am changing first row, R1 changes to R1 plus R2, 1 plus 0, 1 plus 0 is 1, okay. Next, minus 1 plus 1, obviously it is 0. Now 1 plus minus 4 by 5, I write down the calculations here. 1 plus bracketally you write down minus 4 by 5. So take LCM and simplify, it will become, so it is 5, LCM is 5 here, so we get 5 minus 4 divided by 5, that becomes 1 by 5. So therefore this element becomes 1 divided by 5 now. Okay. Yes, second row I am not changing, 0, 1, minus 4 divided by 5. Next, third row I am changing like this, R3 minus 9 times R2. This minus 9 times this is 0. This minus 9 times this is, it is also 0. Now come here, R3 is minus 7, okay, minus this 9 into R2 element is this minus 4 divided by 5. Yeah, you simplify this one, it is minus 7, minus into minus plus 9 fours are 36 divided by 5, that is equal to, LCM is 5, so 7 5s are 35, so we get minus 35 plus 36, so therefore we get 1 divided by 5, so we get 1 divided by 5 here, 1 divided by 5, that's what we get. This is equal to, okay, do the same operation on RHS also. So this plus this, 1 plus of minus 4 by 5, we have done this calculation already here, and the answer turns out to be 1 by 5, so therefore we get 1 by 5 here, 1 divided by 5. Here I get 1 plus of minus 4 by 5, that is 1 by 5. Next, 0 plus 1 by 5, it is 1 by 5 again. Next, 0 plus 0, it is 0. And R2 I am not changing, minus 4 divided by 5, it is 1 divided by 5 and 0. R2 I am not changing. So now R3 changes to R3 minus 9 times R2. So now I am doing calculation separately here. So therefore R3 means it is minus 8 minus 9 into R2 means minus 4 divided by 5. So we get minus 8 plus 36 divided by 5. This is equal to 5 is the LCM. It is minus 8 5s are 40. Minus 40 plus 36. Therefore, this becomes minus 4 divided by 5. Therefore, this element becomes minus 4 divided by 5. Okay. Yeah. Somewhere I have mistaken. What is this element? Minus 7 minus 9 into 4 by 5. This is 1 by 5. Am I right now? Okay, yes, I am right. No problem. Next, how to make this element now? What about this one? R3 minus 9 times R2. This minus 9 times this is 9 into this is minus 9 divided by 5. Minus 9 divided by 5. And this this minus 9 times this is 1 only. Is that right? And carry this A itself. Now tell me what next. So now next step is we have to identify the leading entry of third row. Obviously this is the leading entry of third row. We have to make this 1. How do you make this leading entry 1? Here I having 1 by 5. Okay, have to make this element 1. So I do one thing, multiply the third row by 5, so that 5 gets cancelled, I get 1 here. So therefore what I do is I am applying the operation R3 changes to 5 times R3 now. Okay, with that this element becomes 1 now. So therefore now the matrix is equivalent to 1 0 1 by 5, next 0 1, it is minus 4 divided by 5. Now this element 0 into 5 is 0, 0 into 5 is 0. What is 5 into 1 by 5? 5 gets cancelled, we get 1. This is what we get. Next, this is equal to, this matrix now becomes the first element 1 by 5 as it is, 1 by 5 0, and second row I am not changing, it is minus 4 divided by 5, 1 divided by 5, and it is 0. So now multiplying third row by 5, so that 5 gets cancelled, I get here minus 4, I get here minus 9, 1 into 5 is 5, and carry this A as it is. Okay, tell me what next. Next is we have to make the elements above the leading entry to be equal to 0, so that this matrix turns out to be the identity matrix. Is that right now? So we have to make this element 0, I have to make this element 0. Now tell me what are R1 and R2 operations. So I do one thing, I multiply R3 by 1 by 5 and subtract it from R1. Here also 1 by 5. You make this element to be equal to 1 by 5, so that this minus this becomes 0. So therefore I do the operation like this. Now R1 changes to R1 minus 1 by 5 into R3. Am I right now? Yeah. Next R2 changes to make this element 0. R2 changes to R2 plus 4 divided by 5 into R3. So you think why I am getting here plus sign? Is that right? Okay. So now let us see what happens to the matrices. So this matrix is now equivalent to, yeah. So first row I am changing like this. R1 minus 1 by 5 R3. R1 minus 1 by 5 into 0 is 0 only. 1 minus 0 is 1 only. So we get 1. Next 0 minus 1 by 5, this is we get 0. Okay, so you do one thing, after employing this operation, obviously this matrix turns out to be unit matrix. So therefore you need not bother about the calculations. Simply you write down 1 0 0 0 1 0 0 0 1. Write down like this. This is equal to, now here we have to do the calculations. Okay, yeah. So now I am writing the calculations separately. Okay, yeah. See, R1 minus, so this R1 element is 1 by 5. I am doing calculating the calculations here. 1 divided by 5 minus this 1 by 5, this 1 by 5 into R3 means this minus 4, this element minus 4. So you simplify this, this is 1 by 5 minus into minus plus, it is 4 by 5. You take LCM. Okay, so what is the LCM? LCM is 5, so we get 5. Am I right now? So it is 1 plus 4, that is equal to 5 divided by 5, that is equal to 1. So therefore this element is now becomes 1. Am I right now? Yes. Now come to the next element. R1 is, again this is 1 by 5 minus 1 by 5 into R3 means minus 9. So you simplify this one, 1 by 5 minus into minus plus, it is 9 by 5. You take LCM, LCM is 5, 1 plus 9 is 10, 10 by 5 is 2. So therefore this element becomes 2 now. Okay, next last element, R1 is 0, so we get 0 minus this 1 by 5, this 1 by 5 times R3 means 5, that is R3 means 5. See, 5 gets cancelled, we get 1. So 0 minus 1 is minus 1. so we get minus 1 here. Okay, yeah, this is what is the first row. Next go to the second row. So R2 plus 4 by 5 R3. So R2 means this minus 4 by 5. So I am writing here minus 4 divided by 5, minus 4 by 5 this element, and plus is here plus. So 4 by 5 this element, 4 by 5, 4 by 5 times R3. 4 by 5 times R3 means minus 4 this element. Okay, if I simplify this, so we get minus 4 by 5 minus 4 4 is 16 divided by 5. So how much you get? Minus 4 minus 5 is LCM, you know. Minus 4 minus 16 we get. So minus 20 we get. Minus 20 divided by 4 means 5 4s are 20. So we get minus 4 here. Okay, so next come to this element R2 plus 4 by 5. What is R2? It is 1 divided by 5 plus 4 divided by 5 times R2 this 1 by 5 plus 4 divided by 5 times R3 means minus 9. Okay, yeah, you simplify this. This is 1 by 5 minus 36 divided by 5. So take LCM. LCM is 5. 1 minus 36 is minus 35. Minus 35 by 5. 5 sevens are. So therefore, here I get minus 7. Okay. Next, the last element. Last element is 0. R2 is 0. 0 plus 4 by 5. 4 by 5 times R3 is 5. So that 5 gets cancelled. We get 0 plus 4. 0 plus 4 is 4. And note that I am not changing R3. R3 is minus 4, minus 9 and plus 5, and carry this A as it is. Okay, so now you observe that the matrix what we get is in the form I is equal to A inverse into A or B into A. This is your inverse. So therefore, I will write the answer here. Therefore, inverse A inverse is equal to 1, 2, minus 1, minus 4, minus 7, plus 4, minus 4, minus 9, 5. This is how we have to find out inverse of a matrix by using row operations. Got it? Okay.